1. The stars that witnessed the first dawn. Some stars were born so early in cosmic history that they have quietly watched nearly the entire universe grow up around them. Imagine finding a single tree that has stood quietly since the very first kingdom was built, long before cities covered the landscape, before languages changed, before generations of families came and went. That ancient tree had already been reaching toward the sky. Its branches have watched empires rise and disappear. Its roots have remained still while rivers slowly changed their course. To every traveler passing beneath its leaves, it would seem almost timeless. Now imagine something far older, not centuries old, not thousands of years old, but nearly as old as the universe itself. Somewhere above us tonight, hidden among the countless stars scattered across the darkness, are ancient suns that may have been shining since the universe was still in its earliest childhood. They were already burning when galaxies were only beginning to take shape. They witnessed the birth of enormous clusters of stars. They watched spiral galaxies slowly unfold their graceful arms. Perhaps they even observed entire neighboring galaxies collide, merge, and transform while they themselves quietly continued shining. If stars could remember, these ancient lights would hold the longest memories in existence. Tonight, we'll journey back to the earliest dawn of the cosmos. We'll discover how some extraordinary stars have survived almost the entire history of time itself, why astronomers call them living fossils of the universe, and how these silent witnesses continue carrying stories from an age no human being will ever truly see again. When we look into the night sky, it is easy to imagine that every star is roughly the same. Bright points of light, different colors, different sizes, yet perhaps not very different in age. The truth is wonderfully more complicated. Stars live astonishingly different lives. Some are brilliant giants that burn through their fuel with breathtaking speed. They shine with incredible intensity for only a few million years before ending in spectacular explosions. Others are modest, quiet, patient. They burn their hydrogen so slowly that they can survive for trillions of years, far longer than the universe has even existed so far. These are the true masters of patience. Nature often teaches an unexpected lesson. The brightest things rarely last the longest. Imagine two candles. One has an enormous flame that fills an entire room with light. The other burns softly in the corner. The first candle quickly melts away. The second continues glowing hour after hour. Stars obey much the same principle. Massive stars consume their fuel almost recklessly. Their immense gravity squeezes their cores so intensely that nuclear fusion races forward at extraordinary speeds. They become cosmic fireworks, magnificent, powerful, but short-lived. Small stars behave differently. Their gentle gravity allows fusion to proceed slowly. They waste almost nothing. Every atom of hydrogen becomes precious. Instead of racing through life, they take their time. Some red dwarf stars are expected to continue shining for 10 trillion years or more. To appreciate just how astonishing that number is, consider this. The universe itself is only about 13.8 billion years old. A star capable of living for 10 trillion years has barely begun its existence. If such a star were compared to an 80-year human lifespan, it would still be less than 2 months old. In cosmic terms, the oldest red dwarfs are still children. But among all these patient stars, astronomers have discovered something even more extraordinary. There are stars that formed incredibly early in cosmic history, not long after the first generations of stars began illuminating the darkness. These ancient survivors contain astonishingly small amounts of heavy elements. Astronomers refer to everything heavier than hydrogen and helium as metals. Iron, carbon, oxygen, silicon, gold. Nearly all of these elements were created inside stars. the earliest universe contained almost none of them, only hydrogen, helium, and tiny traces of lithium. Therefore, when astronomers discover a star with almost no heavy elements, they know they are looking into an extraordinarily ancient chapter of cosmic history. One remarkable example is SMSSJ 031300.36-6708339.3. This remarkable star is thought to have formed from material enriched by only one of the universe's earliest supernova explosions. Its chemical composition suggests that it preserves one of the oldest surviving records of stellar history ever discovered. It is less like an ordinary star, and more like an ancient manuscript still waiting to be read. Another fascinating object is the famous Methuselah star, formerly known as HD 140283. Located about 190 light-years away, this quiet star puzzled astronomers for years. Early measurements even suggested it might be older than the universe itself. Of course, the universe cannot contain stars older than its own beginning. Improved observations eventually resolved the mystery, placing its age at roughly 13 to 14 billion years, making it one of the oldest known stars ever observed. Imagine standing beneath a night sky and realizing that one tiny point of light may have been shining before the Milky Way fully became the galaxy we recognize today. Before our sun, before Earth, before every mountain, every ocean, every living creature. That same light quietly continues its journey toward us. These ancient stars are invaluable to astronomers because they act as cosmic time capsules. Unlike planets, stars preserve the chemical fingerprints of the gas clouds from which they were born. Their atmospheres change very little over billions of years. By carefully analyzing their light, scientists can reconstruct conditions that existed when the universe was still astonishingly young. It is rather like finding an untouched fossil buried beneath layers of rock. The fossil itself has survived, but it also tells the story of an entire forgotten world. The earliest stars likely looked very different from those surrounding us today. Many were enormous, some hundreds of times more massive than our sun. Because they contained almost no heavy elements, they burned differently, lived briefly, and exploded with extraordinary violence. Those explosions forged the first generations of carbon, oxygen, iron, and countless other elements. Everything required for rocky planets. Everything required for life. Every atom of calcium inside your bones. Every oxygen atom you breathe. Every iron atom flowing through your blood exists because ancient stars lived and died long before our own solar system was born. Yet while many of those first giants disappeared quickly, some smaller stars quietly survived. They became witnesses, not because they observed with eyes, but because they endured. Every billion years transformed the universe around them. Galaxies merged, black holes grew, new stars ignited, others faded away. Still, these ancient lights continued shining with extraordinary patience. There is something deeply comforting about their existence. Human history often feels impossibly long. Thousands of years seem difficult to comprehend. Ancient civilizations already appear unimaginably distant. Yet these stars remind us that time itself possesses depths far beyond our everyday experience. Entire chapters of cosmic history unfolded before Earth had even begun assembling from dust. And still, the oldest witnesses remain. Perhaps they offer another quiet lesson. Endurance is rarely dramatic. The universe did not preserve these stars because they were the brightest, or the largest, or the most spectacular. It preserved them because they were gentle, efficient, patient. While brilliant giants rushed through their magnificent lives, the quiet stars simply kept burning, one steady heartbeat after another. Perhaps nature often rewards persistence more than brilliance. The night sky seems full of dazzling explosions and dramatic events, But hidden among them are humble stars that have survived almost the entire age of existence. Silent observers, patient companions, living memories of the universe's first morning. And somewhere above us tonight, one of those ancient stars continues shining softly through the darkness, its light leaving long before humanity learned to write, long before our species ever looked upward with curious eyes, still carrying within its gentle glow the quiet memory of a universe just beginning to awaken, patiently reminding us that while civilizations may come and go, and even galaxies slowly change their shapes, some stars simply continue watching as the story of the cosmos unfolds around them. 2. The galaxies hidden inside the darkness. The night sky may appear filled with empty space, yet countless galaxies remain hidden where almost no visible light has ever escaped. Imagine standing on the shore of a calm ocean at midnight. The moon hangs low above the water. The waves shimmer softly beneath its silver light. Looking across the horizon, it seems as though the sea simply ends where darkness begins. Beyond that black line, nothing, or so it appears. But if the sunlight suddenly returned, the empty darkness would transform. Hundreds of distant islands would emerge from the mist. Entire coastlines would appear where moments earlier there seemed to be only empty water. The islands had never been absent, only hidden. The universe plays the same quiet trick upon us every night. When we lift our eyes toward the stars, we naturally believe we are seeing most of what exists. The Milky Way stretches overhead like a glowing river. Thousands of bright stars sparkle against the darkness. A few nearby galaxies reveal themselves as faint patches of light. It feels wonderfully complete. Yet our eyes have been invited to only a tiny corner of the story, beyond the limits of visible light. Hidden inside enormous oceans of darkness lie countless galaxies that remain almost completely invisible. Some are wrapped inside thick clouds of cosmic dust. Others are simply too distant for ordinary light to reach us clearly. Still others shine mostly in forms of light our eyes were never designed to see. Tonight, we'll journey into this hidden universe. We'll discover why darkness is often filled with extraordinary things, how astronomers learn to see galaxies that appear completely invisible, and why some of the greatest cities in the cosmos have spent billions of years quietly waiting beyond the reach of human sight. Human beings have always trusted their eyes. If something shines brightly, we notice it. If something disappears into darkness, we naturally assume there is nothing there. For everyday life, that assumption works remarkably well. But the universe rarely follows human expectations. Visible light is only a tiny part of an enormous spectrum. Imagine sitting beside a grand piano. Now imagine pressing only one key. The sound you hear is real, beautiful, complete in its own way, yet hundreds of other notes remain silent. The universe is much the same. Visible light represents only one small note within an enormous cosmic symphony. Beyond red light lies infrared. Beyond violet lies ultraviolet. Farther still are radio waves, microwaves, X-rays, gamma rays. Each reveals a completely different universe. If our eyes evolved to detect radio waves instead of visible light, the night sky would look almost unrecognizable. The familiar constellations might disappear. Enormous invisible clouds would glow brightly. Jets erupting from distant black holes would dominate the heavens. Entire galaxies, hidden from ordinary vision, would suddenly become impossible to miss. The cosmos has always been speaking. We simply hear only one note. One of the greatest obstacles to seeing hidden galaxies is something surprisingly ordinary: dust. Here on Earth, dust gathers quietly on bookshelves and windows. In space, tiny grains of carbon and silicate drift between stars. Although incredibly sparse, these microscopic particles become remarkably effective at blocking visible light when spread across enormous distances. Imagine trying to see a distant lighthouse through thick fog. The lighthouse continues shining exactly as before. Nothing has happened to its light. The fog simply prevents most of it from reaching your eyes. Many galaxies experience the same fate. Some regions contain vast clouds of dust that absorb visible light almost completely. Inside those dark clouds, stars continue forming. Entire stellar nurseries glow with tremendous energy. Black holes consume surrounding gas. Yet from Earth, almost nothing can be seen. The galaxies seem to vanish. Only when astronomers began observing the universe in infrared light did these hidden worlds finally reveal themselves. Infrared wavelengths pass through dust far more easily than visible light. Suddenly, galaxies once thought to be almost empty burst into extraordinary brilliance. The James Webb Space Telescope has become one of humanity's greatest explorers of this hidden universe. Unlike earlier telescopes that specialized primarily in visible light, Webb was designed to observe infrared wavelengths with extraordinary sensitivity. The results have been breathtaking. Clouds once appearing completely black now reveal thousands of newborn stars. Ancient galaxies emerge from behind curtains of dust. Structures invisible for billions of years quietly step into view. It is rather like watching the sunrise slowly dissolve a morning fog. Nothing new has appeared. We have simply learned to see. Some hidden galaxies remain invisible for an entirely different reason: distance. Light travels incredibly fast, nearly 300,000 kilometers every second. Yet even that astonishing speed requires time. The light leaving a galaxy 10 billion light-years away has spent 10 billion years crossing the expanding universe before finally reaching us. Some galaxies are now so distant that their visible light has stretched into infrared wavelengths during its journey through expanding space. Astronomers call this redshift. Imagine hearing an ambulance drive away. Its siren gradually becomes deeper, lower. The sound waves stretch as the vehicle recedes into the distance. Light experiences something remarkably similar. As the universe expands, the waves themselves become longer. Blue light slowly shifts toward red. Eventually, visible light becomes infrared. A galaxy that once glowed brightly in ordinary light quietly slips beyond human vision. It has not disappeared. Its light has simply changed its language. This is why many of the earliest galaxies can only be observed with infrared telescopes. We are not merely looking across distance. We are looking back through time. Every hidden galaxy becomes another forgotten chapter of cosmic history. There are also galaxies dominated by something even more mysterious: dark matter. Although dark matter itself emits no light whatsoever, its gravity gathers enormous quantities of ordinary matter. Sometimes the visible stars occupy only a tiny fraction of the galaxy's true mass. The brightest regions become like campfires scattered across an enormous invisible landscape. Most of the galaxy remains hidden. Gravity reveals what light cannot. Astronomers often discover these invisible structures through gravitational lensing. Massive galaxies bend light passing nearby, much like a glass lens bends sunlight. By carefully studying these distortions, scientists can detect galaxies too faint to observe directly. The invisible quietly announces its presence by changing the path of light from something farther away. Even darkness leaves fingerprints. Perhaps one of the most astonishing discoveries of recent decades is simply this: there are likely far more galaxies than astronomers once imagined. Earlier estimates suggested roughly 200 billion galaxies filled the observable universe. More recent studies indicate the true number may have been several times larger, especially in the young universe, where countless tiny galaxies remain extremely difficult to detect. Many have merged together over billions of years. Others remain too faint for even our finest instruments. the darkness still keeps many of its secrets. There is something wonderfully humbling about that realization. Every improvement in our technology has not made the universe simpler. It has made it richer. Every new telescope reveals another hidden layer, another forgotten chapter, another population of galaxies patiently waiting beyond the edge of yesterday's understanding. Perhaps the universe is reminding us that reality has never been limited by what we happen to see. Our own lives often unfold the same way. Quiet acts of kindness, hidden struggles, dreams carried silently for years. The most important parts of someone's story are often invisible at first glance. Only patience reveals them. The cosmos seems to share that gentle wisdom. Its brightest galaxies may capture our attention, but its hidden galaxies quietly remind us that darkness is rarely empty. Sometimes, it is simply waiting for us to learn how to see, and somewhere beyond the familiar stars tonight, a forgotten galaxy continues turning slowly through the silence, its newborn suns glowing warmly behind ancient clouds of dust, its invisible halo of dark matter quietly holding everything together, its light patiently crossing billions of years before reaching curious eyes that do not yet exist. Still waiting, not to become real, but simply to be seen. 3. The invisible rivers that never run dry. Long after galaxies seem to have used up their fuel, invisible rivers of ancient hydrogen continue flowing through the cosmos, quietly preparing the next generation of stars. Imagine standing beside an ancient river. Generation after generation has come to its banks. Cities have risen along its shores. Empires have flourished. Others have quietly disappeared into history. Yet the river keeps flowing. It asks for no attention. It celebrates no victories. It mourns no endings. Its waters simply continue their patient journey toward places still waiting to bloom. The universe has rivers like these, only they are not made of water. They are made of the oldest substance in existence, hydrogen. Ancient hydrogen that has been drifting through the cosmos since the universe was still young. Long after bright galaxies appear to have exhausted the gas needed to create new stars, these invisible rivers continue carrying fresh material across millions of light years. Without them, many galaxies would have quietly faded into darkness long ago. Instead, they continue giving birth to new generations of suns. Tonight, we'll follow these hidden cosmic rivers. We'll discover why galaxies never truly live alone, how invisible streams of gas quietly sustain entire stellar civilizations, and why the greatest supply lines in the universe remain almost completely unseen. When we admire a galaxy, it is easy to focus on its stars. They are the brilliant jewels scattered across the darkness. They define the graceful spiral arms. They create the glowing heart at the galaxy's center. Yet stars are only the visible result of a much longer story. Before every star, there was gas. Before every planet, there was gas. Before every living world, there was gas. Hydrogen is the simplest atom in the universe. One proton, one electron, nothing more. Yet from this extraordinary simplicity came nearly everything we know. Every shining star begins as a cloud of hydrogen. Gravity slowly gathers the gas. The cloud cools. It becomes denser. Eventually, the pressure at its center grows so immense that hydrogen nuclei begin fusing into helium. A star is born. It sounds straightforward, but there is a hidden problem. Stars constantly consume hydrogen. Every second, our own sun converts hundreds of millions of tons of hydrogen into helium. Over billions of years, galaxies manufacture astonishing numbers of stars. Surely, they must eventually run out of fuel. For many years, astronomers believed that some galaxies might simply grow old by exhausting their supply of cold gas. Once the fuel disappeared, star formation would slowly come to an end. The galaxy would become quiet, its brilliant youth fading into a peaceful old age. And indeed, many galaxies have reached exactly this stage. Elliptical galaxies often contain ancient populations of stars with very little new star formation. They seem almost retired, their brightest days appearing to lie behind them. Yet even these quiet galaxies are not always completely isolated. The universe has been quietly delivering new supplies all along. Beyond every galaxy lies the intergalactic medium, an enormous ocean of incredibly thin hydrogen stretching between galaxies. At first glance, it appears almost empty. If you could drift through it, you might travel kilometers before encountering even a handful of atoms. Compared with Earth's atmosphere, it is almost perfect vacuum. Yet appearances can be wonderfully misleading. Because this gas fills nearly the entire universe, its total quantity becomes extraordinary. Imagine a gentle mist covering an entire continent. At any single location, it feels almost weightless. But together, the mist contains an immense amount of water. The intergalactic medium behaves in much the same way. Its density is tiny. Its reach is almost endless. Gravity slowly gathers this ancient hydrogen into long filaments stretching across the cosmos. Earlier in our journey, we explored the cosmic web. Those invisible bridges are not empty. They carry rivers. Hydrogen streams patiently along dark matter filaments toward galaxies waiting far downstream. The flow is astonishingly slow, nothing like the rushing rivers of Earth. A single journey may require hundreds of millions of years, sometimes billions. Yet the destination is eventually reached. Fresh gas quietly arrives. Galaxies receive another opportunity to create stars. Astronomers sometimes describe this process as cold accretion. Despite the name, the gas is not truly cold by everyday standards. Rather, it remains cool enough compared with its surroundings that it can continue flowing into galaxies without being completely heated first. Computer simulations suggest that these narrow streams played an especially important role in the young universe. Early galaxies grew rapidly because invisible rivers continuously supplied fresh hydrogen from the surrounding cosmic web. Without those rivers, many galaxies might never have become large enough to resemble the magnificent spirals we admire today. Observing these streams directly is extraordinarily difficult. Hydrogen floating through intergalactic space emits almost no visible light. It prefers silence, so astronomers search for subtle clues. Sometimes distant quasars act like cosmic flashlights. As their brilliant light passes through invisible hydrogen clouds, tiny portions of specific wavelengths become absorbed. These delicate fingerprints reveal rivers that otherwise remain completely hidden. The universe leaves quiet signatures for those patient enough to read them. More recently, powerful observatories have even begun capturing faint glows from enormous hydrogen filaments themselves. Although unimaginably dim, these observations confirm what theory predicted for decades. The rivers are real. They have always been there. We are only now beginning to glimpse them. One beautiful example involves galaxies that appear surrounded by extended halos of hydrogen stretching far beyond their visible stars. These halos function almost like enormous reservoirs. Gas slowly circulates. Some falls inward to create new stars. Some is blown outward by exploding supernovae. Later, gravity gently pulls portions of it back again. The galaxy breathes, not in seconds, nor minutes, but over hundreds of millions of years. Inhale, exhale, again and again. Cosmic breathing. Our own Milky Way participates in this quiet rhythm. Astronomers have discovered immense clouds of hydrogen surrounding our galaxy. Among them are the famous high-velocity clouds, giant collections of gas moving through the galactic halo. Some likely originated outside the Milky Way altogether. Others may represent recycled material ejected by earlier generations of stars. Eventually, portions of this hydrogen will drift inward. Future stars will ignite. Future planets will form. Perhaps future civilizations will someday stand beneath those stars, wondering where they came from. Their story began long before the stars themselves existed. The idea becomes even more comforting when we consider the age of hydrogen. Most of it formed within the first few minutes after the Big Bang, before galaxies, before stars, before planets. The hydrogen fueling tomorrow's stars is almost as old as time itself. The universe has been carefully preserving its original ingredients for nearly 14 billion years. Nothing is hurried, nothing is wasted. Even the deaths of stars contribute to the next beginning. Supernova explosions scatter heavier elements into surrounding space. Those elements mix with incoming hydrogen from the cosmic web. The next generation of stars forms from both ancient simplicity and accumulated history. Every newborn sun contains memories of countless earlier ones. Creation in the universe is never isolated. It is always inherited. Perhaps that is why the cosmos feels so harmonious. Everything gives, everything receives. Invisible rivers feed galaxies. Galaxies create stars. Stars forge new elements. Those elements return to space. Fresh hydrogen arrives once more. The cycle quietly continues, not endlessly, but patiently. There is something deeply reassuring about this rhythm. We sometimes imagine that running out is inevitable, that every beautiful thing must eventually exhaust itself. The universe offers a gentler perspective. As long as quiet rivers continue flowing, new beginnings remain possible, even after billions of years. Even after countless stars have already lived and died, the oldest hydrogen in existence still carries tomorrow inside it. Perhaps our own lives unfold similarly. We often believe progress comes through dramatic moments, great discoveries, sudden transformations, remarkable achievements. Yet much of what sustains us arrives quietly. Conversations that restore hope, friendships that continue across decades, small kindnesses offered without expectation, like invisible rivers. The greatest sources of renewal often flow unnoticed. The cosmos seems to understand this better than anyone. Its brightest stars may capture our attention, but the invisible rivers patiently feeding them have never demanded applause. They simply continue flowing. And somewhere tonight, far beyond the familiar glow of the Milky Way, an ancient stream of hydrogen is quietly drifting along an invisible filament of dark matter, crossing millions of light years with extraordinary patience, carrying within its silent current the raw material for stars that have not yet been born, worlds that have not yet formed, and perhaps, one distant evening, a curious mind that will look up into its own night sky and wonder where all the stars first came from. If these peaceful journeys through the universe help you unwind before sleep, consider subscribing so we can continue discovering its hidden wonders together. 4. The places where gravity whispered first before the first star ever shined. Gravity had already begun quietly shaping the places where entire galaxies would one day appear. Imagine walking through an enormous cathedral before anyone has placed the first stone. There are no towering walls, no stained glass windows, no graceful arches reaching toward the sky, only an empty field stretching into the distance. To every passerby, it would seem like ordinary land, nothing remarkable, nothing worthy of history. Yet, beneath the quiet surface, the architect already carries the entire building in mind. Every column has a place. Every doorway has a purpose. Every future echo has already been imagined. The cathedral exists long before anyone can see it. The universe began much the same way. Long before the first sunrise illuminated the darkness, long before galaxies spun graceful spiral arms across space, long before planets circled newborn stars. Gravity had already begun drawing an invisible map of everything that would eventually come to exist. It never shouted. It never rushed. It simply whispered, patiently gathering tiny differences in matter, quietly preparing places where galaxies would one day bloom. Tonight, we'll travel back to an age before starlight itself. We'll discover how gravity became the universe's very first architect, why the earliest structures formed long before anything could actually be seen, and how every galaxy shining above us tonight may still be following instructions written during the first moments after time itself began. When we picture the beginning of the universe, many of us imagine an explosion, a sudden burst of light, chaos racing in every direction. While that image captures a sense of tremendous energy, it misses something surprisingly gentle. The young universe was astonishingly smooth. After the Big Bang, matter spread throughout space with remarkable uniformity. Hydrogen and helium filled the expanding cosmos almost evenly. If someone could somehow have looked across this early universe, they would not have seen stars or galaxies, only an immense glowing sea of hot plasma stretching endlessly in every direction. At first glance, it appeared almost perfectly balanced, but perfection is extraordinarily rare in nature. Hidden within that smooth ocean were tiny imperfections, not mountains, not valleys, only incredibly small differences in density. Some regions contained just a little more matter than others. Imagine laying a perfectly calm blanket across a bed. From across the room, it looks completely flat. Yet upon closer inspection, tiny wrinkles gently rise from the fabric, hardly noticeable, almost insignificant. Yet those tiny wrinkles change how the blanket settles. The early universe contained similar wrinkles, except instead of fabric, the wrinkles existed within matter itself. Those tiny variations were unbelievably small, only about 1 part in 100,000. If the universe had been even slightly smoother, galaxies might never have formed. If the differences had been much larger, matter might have collapsed too quickly, creating a very different cosmos altogether. The balance was astonishingly delicate. Gravity noticed those tiny imperfections immediately. Unlike light, which simply travels onward, gravity always pauses. It always listens. Whenever a region contains even slightly more matter than its surroundings, gravity quietly strengthens there. The extra mass attracts additional material. That new material increases gravity even further. Slowly, almost imperceptibly. The dense region grows denser still, not because gravity forces matter violently inward, but because it patiently invites it. One atom, then another, then millions, then entire clouds. The whisper gradually becomes impossible to ignore. This process continued for millions of years before the first stars ever existed. There was no visible light announcing the transformation, no brilliant explosions, only invisible motion. Dark matter played an especially important role during this quiet era. Although we cannot see dark matter directly, astronomers believe it outweighs ordinary matter by roughly 5 to 1. Most importantly, dark matter does not interact with light the way ordinary gas does. While hot hydrogen remains supported by pressure, dark matter could begin collapsing into clumps much earlier. It became the universe's hidden scaffolding. Imagine constructing an enormous city. Before the beautiful buildings appear, workers first assemble steel frameworks. Those beams remain hidden inside the finished skyscrapers. Yet without them, nothing else could stand. Dark matter provided that invisible framework for the cosmos. Gravity first gathered dark matter into enormous halos. Only later did ordinary hydrogen begin falling into those prepared structures. In many ways, galaxies did not choose where to appear. Gravity had already chosen for them. Modern computer simulations reveal this astonishing process with breathtaking beauty. Scientists begin with conditions measured from the early universe. Then, they allow gravity to work according to the known laws of physics. Billions of years pass inside the simulation. Slowly, tiny fluctuations become filaments. Filaments gather intersections. Galaxies emerge exactly where gravity quietly prepared space for them long before. Watching these simulations feels almost like observing frost spread across a winter window. At first, nothing. Then delicate branches begin extending. Soon intricate patterns connect into something breathtaking. No one draws each crystal individually. Simple rules repeated with extraordinary patience create astonishing complexity. The universe behaves in much the same way. Astronomers have found remarkable evidence supporting this picture through observations of the cosmic microwave background. This faint glow is the oldest light we can observe, released about 380,000 years after the Big Bang. Although it appears astonishingly uniform, careful measurements reveal those same tiny fluctuations in temperature and density. They are the earliest fingerprints of future galaxies. Looking at the cosmic microwave background is rather like examining the first sketch beneath an artist's painting. The finished masterpiece does not yet exist, yet every important feature has already been outlined. One of the most beautiful realizations in modern cosmology is that gravity is incredibly patient. On Earth, we often think of gravity as immediate. Drop a stone, it falls instantly. Watch rain descend from the clouds. Everything seems quick. But across cosmic distances, gravity works with extraordinary gentleness. Entire galaxies require hundreds of millions or even billions of years to fully assemble. Nothing is hurried. Nothing is forced. Imagine watching a mountain rise, not over centuries, but grain by grain, each grain almost meaningless on its own. Yet together, given enough time, they become continents. Gravity builds galaxies with similar persistence. There is no deadline, only steady progress. This patient construction explains why the universe remains active even today. Gravity has never stopped working. New dwarf galaxies continue forming. Gas still flows toward larger systems. Galaxy clusters continue gathering. Even our own Milky Way quietly pulls smaller neighboring galaxies toward itself. The whispers spoken billions of years ago have never truly fallen silent. They simply continue echoing. Perhaps this changes the way we think about beginnings. We often imagine beginnings as dramatic moments, a curtain rising, a spark igniting, a race suddenly starting. The universe suggests something quieter. Perhaps true beginnings happen long before anyone notices them, long before the first flower blooms. Its roots are already growing. Long before the first sunrise, gravity has already prepared the horizon. Long before the first galaxy shines, invisible structures have patiently been taking shape inside the darkness. The greatest creations may begin in silence. There is comfort in that thought. Our own lives often seem unchanged for long periods. Progress feels invisible. Dreams appear distant. Yet, beneath the surface, quiet foundations may already be forming. The universe rarely mistakes stillness for absence. Its grandest masterpieces often spend millions of years hidden before anyone recognizes what they are becoming. Gravity has always understood this secret. It never demanded attention. It never announced its achievements. It simply continued whispering. One tiny fluctuation, one invisible halo, one future galaxy at a time. And somewhere beyond the oldest light still reaching Earth tonight, gravity continues speaking in that same gentle voice, gathering invisible rivers of hydrogen toward places where tomorrow's stars will someday awaken, strengthening quiet halos that no eye will ever directly see, patiently shaping galaxies that have not yet fully been born, still following the first whispers spoken almost 14 billion years ago, when the universe itself was little more than possibility. and gravity quietly began writing the map that every future star would eventually call home. 5. The oceans between every star. The emptiness between stars isn't truly empty. It is filled with an ancient ocean of invisible gas that slowly connects the entire galaxy. Imagine standing on a quiet beach long after sunset. The ocean has almost disappeared into the darkness. No crashing waves, no glittering reflections beneath the moon, only silence stretching toward the horizon. From where you stand, it almost feels as though the sea itself has vanished. But the water is still there. Every current continues flowing beneath the darkness. Every tide continues rising and falling. Every unseen wave remains connected to every distant shore. The ocean never stopped existing. It simply became invisible. The space between the stars is much the same. When we gaze into the night sky, we naturally imagine each star floating alone inside an immense emptiness. Tiny islands of light surrounded by perfect nothingness. The darkness appears absolute. The distances seem impossible, yet the universe is rarely as empty as it first appears. Between every star, between every glowing nebula, between every planetary system, there stretches an enormous, nearly invisible ocean of ancient gas. It drifts so quietly that generations of civilizations could pass without ever noticing its gentle currents. Yet, this hidden sea connects the entire Milky Way together. It feeds newborn stars, carries the ashes of ancient suns, preserves the raw material for future planets, and quietly reminds us that even the greatest distances in the universe are never truly empty. Tonight, we'll drift into this forgotten ocean. We'll discover why the galaxy is more connected than it appears, how invisible gas becomes the bloodstream of the cosmos, and why every breath you take contains atoms that once floated through this silent sea between the stars. When early astronomers observed the night sky, the spaces between stars appeared completely black. It was an understandable conclusion. Even through powerful telescopes, there seemed to be nothing to see. Stars shined brilliantly. Nebulae glowed softly. Everything between them looked empty. For centuries, that darkness was mistaken for absence. Only during the 20th century did astronomers slowly realize that the galaxy was filled with something they had overlooked all along. The emptiness wasn't empty. It was astonishingly thin. The space between stars is occupied by what scientists call the interstellar medium. This vast mixture of hydrogen, helium, microscopic dust grains, magnetic fields, and energetic particles fills nearly every corner of our galaxy. It is so diffuse that even the finest laboratory vacuum on Earth contains far more particles than most regions of interstellar space. In some places, there may be only a single hydrogen atom inside a volume the size of a sugar cube. At first, that sounds almost like nothing, yet the Milky Way is unimaginably large. Stretch that tiny density across 100,000 light years, and suddenly the total amount of matter becomes enormous. Imagine a gentle morning mist covering an entire mountain valley. At any single point, the mist feels almost weightless. You could walk through it without resistance, but viewed from above, it blankets the entire landscape. The interstellar medium behaves in much the same way. Its strength lies not in density, but in scale. It is everywhere. Hydrogen dominates this invisible ocean. That should perhaps come as no surprise. Hydrogen has been the universe's favorite element since the very beginning. Created only minutes after the Big Bang, it became the original building material from which nearly every future star would emerge. Much of that ancient hydrogen still drifts peacefully through the galaxy today. Some of it has never entered a star at all. It has simply continued floating, patiently waiting for gravity to invite it somewhere new. Within this ocean, the gas is far from uniform. Some regions remain incredibly thin. Others slowly gather into gentle clouds. Given enough time, gravity encourages these clouds to become denser. Temperatures fall, pressure rises. Eventually, enormous molecular clouds begin taking shape. These dark clouds are among the largest individual structures inside the Milky Way. Some stretch hundreds of light years across. Inside them, future stars are quietly sleeping. Astronomers often describe these clouds as stellar nurseries. The comparison feels almost perfect. A nursery is not defined by what already exists. It is defined by what is patiently becoming possible. Inside these cold clouds, gravity continues its patient work. Tiny regions collapse. Dense cores appear. One by one, new stars ignite. Every brilliant sunrise in the galaxy begins inside this quiet ocean. Yet the story does not end there. Stars are not merely born from the interstellar medium. They also reshape it. Young stars produce powerful winds that push surrounding gas outward. Massive stars flood nearby space with intense ultraviolet radiation. When the largest stars finally explode as supernova, enormous shock waves race through the surrounding gas, compressing some clouds while scattering others. The ocean never remains still. It breathes, it stirs. It remembers every generation of stars that has passed through it. Imagine watching rain fall into a vast lake. Later, the lake slowly feeds rivers. The rivers nourish forests. The forests release moisture back into the sky. Eventually, rain falls once more. Nothing truly disappears. It simply changes form. The interstellar medium follows a similar cycle. Stars form from gas. Stars create heavier elements. Those elements return to space. Fresh clouds emerge. New stars are born again. The galaxy quietly recycles itself. One of the most fascinating discoveries in modern astronomy is that much of this gas is constantly moving. Although space appears motionless, enormous invisible currents flow throughout the Milky Way. Some clouds drift gently through spiral arms, others fall toward the galactic center. Supernova explosions launch expanding shells across dozens or even hundreds of light years. Magnetic fields guide charged particles through the darkness. The ocean possesses weather, not weather measured in hours, but in millions of years. If human eyes could somehow perceive hydrogen directly, the night sky would become almost unrecognizable. Instead of isolated stars floating inside empty darkness, we would see an immense glowing sea surrounding every constellation. Delicate streams would connect distant nebulae. Great clouds would drift between familiar stars. Invisible waves would roll across spiral arms. The Milky Way would resemble a luminous coastline rather than a collection of scattered lights. Perhaps the stars themselves would no longer seem like the main attraction. Instead, they would appear as bright islands rising above an endless cosmic sea. Astronomers have learned to map portions of this hidden ocean using radio telescopes. Neutral hydrogen naturally emits radiation at a wavelength of 21 centimeters, one of the most important signals in all of astronomy. Unlike visible light, this radio emission passes easily through many clouds of dust. By listening carefully to these gentle whispers, scientists have traced enormous hydrogen structures extending across the galaxy. The Milky Way has become not only something we observe, but something we can quietly listen to. The ocean speaks, not with crashing waves, but with radio whispers traveling through the darkness. Even more remarkable is the realization that every atom inside our own bodies has participated in this great cycle. The oxygen we breathe, the carbon forming our cells, the calcium inside our bones. These heavier elements were created inside stars long ago. When those stars died, their material returned to the interstellar medium. For millions of years, perhaps billions, those atoms drifted through the invisible ocean before eventually becoming part of the cloud that formed our sun and Earth. In a very real sense, we once floated between the stars. There is something profoundly comforting about that thought. The galaxy is not a collection of isolated objects. It is a connected living system. Every star receives, every star gives. Nothing truly stands alone. The invisible ocean quietly links everything together. Perhaps our own lives reflect the same hidden truth. We often notice only the brightest moments, achievements, celebrations, great turning points. Yet beneath those visible events flow quieter currents. Conversations that change us, memories carried across decades, acts of kindness that continue influencing lives long after they are forgotten. Like the interstellar medium, the invisible connections often matter most. The universe has always understood this. Its greatest ocean has never sought attention. It does not sparkle like stars. It does not blaze like supernova. It simply continues carrying tomorrow through the silence, patiently, faithfully, one invisible current at a time. And somewhere beyond the familiar constellations tonight, an ancient cloud of hydrogen is drifting slowly through the Milky Way, passing between stars that have already lived for billions of years, carrying within its gentle currents the ingredients for future suns, future planets, perhaps even future dreamers who will one night lift their eyes toward the heavens, never realizing that long before their own star was born, its first breath had already begun. Inside the quiet ocean between every star, 6. The worlds that outlived their neighbors. Some lonely worlds may continue drifting through space long after every nearby star has disappeared into history. Imagine visiting a small village nestled among quiet mountains. Every house is filled with warm light. Children laugh in the streets. Smoke rises gently from chimneys as evening settles across the valley. It feels timeless, alive. Then imagine returning many centuries later. The houses are gone. The roads have faded beneath grass. The voices have long since fallen silent. Only a single stone well remains, standing patiently beneath the same sky. The people disappeared. The village became history. Yet one quiet survivor continued waiting. The universe may contain places very much like that forgotten well. Lonely worlds that remain long after the brilliant stars surrounding them have vanished. Planets that continue their endless journeys through darkness, even after the neighborhoods they once called home have changed beyond recognition. Some may have been gently pulled away from their original stars, becoming wanderers between galaxies. Others may still orbit ancient stars whose brightest days are already far behind them. And in the unimaginably distant future, when many familiar constellations have disappeared forever, countless worlds may still exist, cold, silent, and remarkably patient. Tonight, we'll travel far beyond the comfortable lifetime of stars. We'll discover why planets can sometimes outlive the brilliant suns that first illuminated their skies, how entire planetary systems slowly change as the universe grows older, and why some of the last surviving worlds may continue drifting through the darkness long after nearly every familiar landmark has faded into memory. When we think about planets, we almost always think about their stars. Earth belongs to the Sun. Jupiter circles the Sun. The magnificent worlds discovered around distant stars seem inseparable from the brilliant lights they orbit. It feels natural. After all, without a star, what is a planet? Yet the universe quietly reminds us that stars and planets experience time very differently. A star is alive in a physical sense. Deep within its core, nuclear fusion constantly transforms hydrogen into helium. The star shines because enormous amounts of energy are being created every second. But that energy comes from a limited supply of fuel. Eventually, every star changes. Small stars do so gently. Massive stars do so dramatically. No matter their size, however, every star is destined to evolve. Planets follow different rules. A planet does not generate its own light through fusion. It simply exists. A world made of rock or ice can remain structurally stable for astonishingly long periods of time. Its mountains slowly erode. Its interior gradually cools. Its atmosphere may change. Yet, unless something catastrophic happens, the planet itself can survive far beyond the active lifetime of the star that once warmed it. Imagine an old fireplace. For years, it fills a room with warmth. One evening, the fire finally burns out. The flames disappear. The glowing embers fade. But the stone fireplace itself remains. Long after the heat has vanished, the structure quietly continues standing. Planets are often like those silent stones. They endure. Our own solar system offers a glimpse of this distant future. About 5 billion years from now, the sun will exhaust the hydrogen in its core. It will slowly swell into a red giant, growing large enough to dramatically transform the inner solar system. Mercury will almost certainly disappear. Venus is expected to be consumed as well. Earth's fate remains uncertain, though most models suggest it will become completely uninhabitable long before then. Its oceans will vanish. Its atmosphere will be stripped away. Its surface will melt beneath the increasing heat. Life, as we know it, will already have become impossible. Eventually, the sun will shed its outer layers, leaving behind a glowing planetary nebula surrounding a tiny white dwarf. The brilliant star that once dominated the sky will become something no larger than Earth itself. Yet many of the outer planets will remain: Jupiter, Saturn, Uranus, Neptune. Their frozen moons. Countless dwarf planets beyond Neptune. Although transformed by billions of years, much of the solar system will still exist. The sun will have entered old age. Its family will quietly continue orbiting. White dwarfs are extraordinary objects, roughly the size of Earth, yet containing about half the sun's mass. They no longer create new energy through fusion. Instead, they slowly radiate away the heat left from their earlier lives. That cooling process is astonishingly slow. Some white dwarfs will remain warm for trillions of years. Any surviving planets will continue circling them through unimaginable stretches of time. The sky above those worlds would change forever. No brilliant yellow sun, no bright blue daytime, only a small white ember glowing softly against eternal darkness. Some astronomers have even discovered planets that already orbit white dwarfs, proving that planetary systems can indeed survive dramatic stellar evolution. But planets do not always remain with their original stars. The universe is surprisingly restless. Stars pass one another. Galaxies merge. Gravitational encounters constantly reshape planetary neighborhoods. Sometimes, a passing star comes close enough to disturb another system. Its gravity gently tugs at distant planets. Occasionally, one of those worlds escapes entirely. Astronomers call them rogue planets. These lonely travelers no longer orbit any star. Instead, they drift independently through interstellar space. Some may have been wandering for billions of years already. Imagine standing upon such a world. There would be no sunrise, no sunset, no familiar seasons. Only the distant glow of countless stars scattered across an endless black sky. If the planet retained a thick atmosphere or internal heat, generated by radioactive elements beneath its surface, hidden oceans might continue existing far below layers of ice. Life, at least in theory, might even survive there without sunlight. The universe is often more imaginative than we are. As time continues, the galaxy itself changes. Stars slowly consume their fuel. New star formation gradually decreases as available hydrogen becomes less abundant. Billions upon billions of years from now, many galaxies will become quieter places. The brilliant spiral arms we admire today may fade as fewer young blue stars appear. Older red stars will dominate the night. Eventually, even those will evolve. Yet many planets will still remain silent, cold, faithful to orbits that no longer resemble the lively systems in which they were born. Looking even farther into the future becomes almost dreamlike. After trillions of years, nearly all ordinary stars will have completed their evolution. White dwarfs, neutron stars, black holes. These compact remnants will populate an increasingly dark universe. Some planets may still orbit them. Others will have been ejected into the growing emptiness between the stars. These ancient worlds will become some of the longest-lasting solid objects in existence, not because they are indestructible, but because time itself moves so gently across stone and ice. There is something deeply moving about these forgotten worlds. Throughout history, human beings have often measured importance by brightness. The loudest voices, the greatest victories, the brightest stars. Yet, the universe quietly suggests another measure: endurance. The worlds that outlive their neighbors are not necessarily the largest, nor the most beautiful, nor the most spectacular. They simply continue, patiently, without asking to be remembered. Perhaps that quiet persistence carries its own kind of beauty, even after their suns have faded, even after nearby stars have disappeared, even after familiar constellations have dissolved into history. They continue drifting beneath skies that grow darker with every passing age, still carrying mountains, still carrying valleys, still carrying the silent memory of mornings that ended billions of years ago. Perhaps they remind us that every place carries its history long after the events themselves have passed. Ancient forests remember vanished rivers, mountains remember forgotten oceans, planets remember lost suns. The universe itself seems built upon memory, not written in words, but preserved in orbits, in stone, in ice, in quiet endurance, and somewhere beyond the reach of our telescopes tonight. A lonely world continues circling the faint white ember of a star that once blazed like our own sun, its frozen mountains untouched for billions of years, its endless night illuminated only by distant galaxies, patiently completing one orbit after another, long after every neighboring star that once filled its sky has faded into history, still traveling, still waiting, still carrying the silent memory of a brighter universe that only it can remember. 7. The first threads of the cosmic web. Long before galaxies painted the night sky, invisible threads had already begun weaving the enormous structure of the universe itself. Imagine opening an old tapestry that has been folded away for centuries. At first, your eyes notice only the beautiful images woven across its surface. Mountains, forests, rivers, entire kingdoms stitched together in brilliant color. But as you look more carefully, you realize that none of those pictures could exist without something much simpler. Thousands upon thousands of tiny threads. Most disappear beneath the surface. Few are ever noticed. Yet every mountain, every river, every golden sunrise depends entirely upon them. Remove the threads, and the entire tapestry falls apart. The universe has a tapestry of its own. When we look into the night sky, we naturally admire the bright galaxies scattered across the darkness. Elegant spirals, towering elliptical galaxies, glowing clusters containing hundreds of trillions of stars. They seem like separate islands floating through an endless sea of empty space. But they are not separate at all. Hidden beneath the visible universe lies an immense network of invisible threads stretching across billions of light years. Long before the first galaxy ever existed, before the first star illuminated the darkness, these delicate structures had already begun quietly connecting the future universe together. Tonight, we'll follow the earliest threads ever woven across the cosmos. We'll discover how invisible filaments became the framework for everything we see today. Why galaxies almost never grow alone, and how the largest structure ever discovered began forming long before light itself could reveal its extraordinary design. If you could somehow travel backward through time, past the birth of Earth, past the formation of our sun, past the first galaxies. Eventually, you would arrive in a universe unlike anything we recognize today. There would be no familiar constellations, no glowing spiral galaxies, no brilliant nebulae, only a vast expanding ocean of hydrogen, helium, dark matter, and radiation. At first glance, everything would appear almost perfectly smooth. Almost, because hidden within that remarkable uniformity were incredibly tiny differences. Some regions contained ever so slightly more matter than others. Not enough for anyone to notice with ordinary eyes. Yet gravity noticed immediately. Gravity has extraordinary patience. It never demands dramatic beginnings. It simply starts wherever there is even the smallest imbalance. A tiny region containing just a little more matter exerted slightly stronger gravity. That stronger gravity attracted additional material, which strengthened gravity even further. Little by little, the difference slowly grew. Imagine rain falling across a perfectly flat field. If one shallow depression lies hidden beneath the grass, water begins collecting there first. As more water gathers, the depression becomes deeper. Soon, even more rain flows toward the same place. The process quietly reinforces itself. Gravity works in much the same way. Small differences become larger. Tiny fluctuations become enormous structures. Nothing happens quickly. Everything happens steadily. Dark matter became the first great builder of this invisible network. Unlike ordinary gas, dark matter does not interact with light. It neither shines nor absorbs radiation. Because of this, it began collapsing into structures much earlier than ordinary matter could. Enormous halos formed. Long filaments stretched outward. Intersections gradually appeared where several filaments crossed. The cosmic web was beginning to emerge. No stars marked its outline. No galaxies decorated its intersections. The universe was quietly constructing its invisible skeleton long before anyone could have imagined the finished masterpiece. Modern supercomputer simulations reveal this breathtaking process in astonishing detail. Scientists begin with the tiny fluctuations measured in the cosmic microwave background. Then they simply allow gravity to operate according to the known laws of physics. Millions of years pass, then hundreds of millions. Gradually, delicate strands begin stretching through space. Some merge together, others branch apart. Great knots form where multiple filaments intersect. Eventually, galaxies begin appearing exactly where those invisible crossings had already been prepared. Watching these simulations feels strangely familiar. It resembles frost spreading across a winter window, or roots branching beneath the soil, or veins growing inside a leaf. Nature seems to enjoy building complex beauty from remarkably simple rules. The universe may be larger than anything we can imagine, yet it often creates with astonishing elegance. Today, astronomers call this immense network the cosmic web. It may be the largest structure in existence. Its filaments stretch across hundreds of millions of light years. Galaxy clusters gather where multiple strands intersect. Between those threads lie enormous cosmic voids, vast regions containing remarkably few galaxies at all. If the entire observable universe could somehow be viewed from impossibly far away, it might resemble an enormous three-dimensional spiderweb suspended through the darkness. Except, instead of silk, the threads would consist largely of dark matter, hydrogen, and diffuse gas. And instead of insects, entire galaxies would rest upon the intersections. One remarkable discovery is that galaxies rarely appear randomly scattered. They prefer company. Gravity quietly encourages them to gather along these invisible highways. Fresh hydrogen flows through the filaments. Dark matter strengthens the gravitational pull. Galaxy clusters slowly grow larger as more material arrives. Even today, billions of years after the first threads began forming, the cosmic web remains active. Construction never truly stopped. One of the most fascinating examples of these invisible highways comes from enormous galaxy clusters. These giant collections often contain hundreds or even thousands of galaxies bound together by gravity. But they did not appear independently. Most were slowly assembled where multiple cosmic filaments converged. Each filament delivered galaxies, gas, and dark matter toward the same destination. Imagine countless rivers flowing into a single peaceful lake. The lake becomes larger because every river quietly contributes. Galaxy clusters grow in much the same way. Invisible roads continuously bring new travelers home. Astronomers have even begun observing portions of these hidden filaments directly. Although dark matter itself remains invisible, the hydrogen gas flowing along the cosmic web sometimes emits an extraordinarily faint glow. Sensitive telescopes have detected delicate bridges connecting neighboring galaxy clusters. Gravitational lensing also reveals the invisible mass stretching between them. Light bends, galaxies distort. The hidden threads quietly reveal themselves through the influence they exert on everything around them. Even when we cannot see the thread itself, we can watch the universe gently pulling against it. Perhaps the most beautiful realization is that every familiar object owes something to this ancient network. Our Milky Way exists where it does because of the cosmic web. The local group of galaxies formed where invisible filaments gathered matter together over billions of years. Even the hydrogen that eventually became our sun likely traveled along these quiet highways long before the solar system existed, in a very real sense. Our own story began upon one of these ancient threads. There is something deeply comforting about this image. The universe often appears chaotic. Galaxies collide, stars explode, black holes consume matter. Everything seems unpredictable. Yet beneath that magnificent activity lies quiet order, invisible connections, patient structure, gentle guidance. The cosmic web reminds us that beauty often grows from relationships rather than isolation. No galaxy truly stands alone. Each belongs to something vastly larger than itself. Perhaps our own lives are not so different. We often notice the visible moments, the achievements, the celebrations, the milestones everyone can see. But beneath those moments lie invisible threads: family, friendship, kindness, small conversations that quietly changed our direction years ago. Like the cosmic web, the strongest connections are often the ones least visible. The universe has been weaving them since almost the beginning of time. Not hurriedly, not dramatically, but with extraordinary patience, one delicate thread at a time, and somewhere beyond the farthest galaxy visible tonight, another invisible filament continues stretching silently through the darkness, guiding ancient rivers of hydrogen toward galaxies that have not yet fully grown, binding enormous clusters together across distances almost impossible to imagine, still weaving the same magnificent tapestry it first began nearly 14 billion years ago. One quiet thread, connecting everything. If you're enjoying these relaxing stories from across the cosmos, subscribing helps us continue exploring one peaceful mystery at a time. 8. The ancient clouds waiting to become suns. Across the silent universe, enormous clouds have been patiently gathering for billions of years, still waiting for the moment their first stars will finally awaken. Imagine walking through an ancient forest just before sunrise. The trees stand perfectly still. Not a single bird is singing yet. No breeze stirs the leaves. Everything feels asleep. If someone arrived at that quiet moment, they might believe nothing was happening at all. Yet beneath the soil, countless roots are carrying water. Inside every branch, tiny cells are preparing for the coming daylight. The flowers are only moments away from opening. The forest is not asleep, it is waiting. The universe contains places just like that. Enormous clouds stretching across hundreds of light years drift silently through the darkness. From a distance, they appear lifeless, cold, empty, motionless. But inside these vast invisible kingdoms, gravity has been quietly preparing a remarkable future for billions of years. Every gentle movement, every tiny collapse, every invisible current brings them one step closer to creating entirely new suns. Some of these ancient clouds have existed longer than our solar system itself. Some may still wait millions of years before their first star is finally born. Tonight, we'll drift into these quiet stellar nurseries. We'll discover why stars spend far longer preparing to exist than they spend announcing their arrival. How the coldest places in the galaxy quietly become its brightest. And why some of tomorrow's suns are already patiently sleeping inside clouds that have never yet seen a sunrise. When most people imagine the birthplace of a star, they picture something dramatic: violent explosions, blinding flashes of light, immense heat bursting across the darkness. Nature often chooses a gentler beginning. Before a star becomes brilliant, it begins as silence. The galaxy is filled with enormous molecular clouds. These are among the largest individual objects inside the Milky Way. Some contain enough gas to create hundreds of thousands of stars. Others hold millions of times the mass of our sun. Yet despite their enormous size, they are surprisingly cold. Many exist at temperatures of only 10 or 20 degrees above absolute zero. To human imagination, cold often feels lifeless. But in the universe, cold is frequently the beginning of creation. Warm gas moves quickly. Its particles constantly collide and scatter. Gravity struggles to pull it together. Cold gas behaves differently. Its atoms move more slowly. They settle. They gather. Gravity finally begins gaining the upper hand. Imagine watching snowflakes fall into a peaceful valley. At first, each flake lands almost unnoticed. Hours pass. The landscape slowly changes. Nothing dramatic ever occurs. Yet by morning, an entirely different world has quietly appeared. Gravity builds stars with the same remarkable patience. One atom joins another, then countless more. Over millions of years, tiny regions inside the cloud become slightly denser than everything around them. Those denser pockets attract additional gas. Their gravity strengthens. The collapse slowly accelerates. Still, no light, no fire, only gathering. Astronomers sometimes call these regions dense cores. They are the hidden cradles of future stars. Many are only a fraction of a light year across. Compared with the enormous molecular cloud surrounding them, they seem almost insignificant. Yet nearly every star begins inside one of these quiet pockets. The future often starts in surprisingly small places. If we could somehow watch one of these cores evolve in fast motion, the process would resemble a slow breath. The surrounding gas gently falls inward. Pressure increases. Temperatures begin rising. The center grows steadily denser. Eventually, a tiny object called a protostar forms. Despite the name, it is not yet a true star. Fusion has not begun. No sunlight shines outward. Instead, the young protostar glows faintly from the heat generated by its gradual collapse. Gravity itself provides the energy. The first light of a future sun is born not from nuclear fire, but from falling. One of the most beautiful discoveries made by astronomers is that stars almost never form alone. Inside these ancient clouds, dozens, hundreds, sometimes thousands of protostars emerge together. Entire families awaken within the same nursery. The famous Orion molecular cloud, visible from Earth in the direction of Orion's belt, continues producing new stars even today. Hidden behind curtains of dust lie countless infant suns only a few 100,000 years old. In cosmic terms, they are newborns. Their surrounding disks of gas and dust may eventually become planets. Perhaps one day, some of those planets will carry oceans, mountains, living forests, curious civilizations. The future of entire worlds already exists inside clouds, that appear almost completely dark. The clouds themselves are remarkably long-lived. Some survive for tens of millions of years before most of their stars finally ignite. Others are constantly renewed as fresh hydrogen flows into them from the surrounding galaxy. Our journey through the invisible rivers taught us that hydrogen never truly stops moving. The galaxy continues supplying fresh material. The nurseries continue waiting. The cycle quietly repeats. One particularly fascinating type of cloud is known as a Bok globule. These are small, isolated pockets of especially dense gas and dust. When photographed against bright backgrounds, they appear like tiny black droplets floating through glowing nebulae. To ordinary eyes, they seem to contain nothing at all. Yet inside many Bok globules, astronomers have discovered protostars quietly growing toward adulthood. Darkness often hides extraordinary beginnings. The James Webb Space Telescope has recently offered breathtaking views into these stellar nurseries. Because infrared light passes through dust far more easily than visible light, Webb can peer deep inside clouds that once appeared completely opaque. There, it has revealed delicate filaments of gas, glowing newborn stars, and intricate structures sculpted by gravity. Regions that once seemed empty have become landscapes filled with quiet creation. It feels almost like discovering an entire city hidden beneath morning fog. The city was never absent. Our vision simply wasn't ready. Eventually, something remarkable happens inside every successful protostar. As gravity continues compressing its core, temperatures climb to nearly 10 million degrees. Hydrogen nuclei begin moving so rapidly that they overcome their natural electrical repulsion. They collide, they fuse. A tiny portion of their mass transforms directly into energy. For the first time, a true star awakens. The pressure from nuclear fusion finally balances gravity's relentless inward pull. The collapse stops. A stable sun begins shining. The long waiting has ended. Yet, in another sense, it has only just begun. Many stars will continue burning for billions or even trillions of years. Compared with their astonishing lifetimes, their birth feels almost like a single heartbeat. There is something profoundly peaceful about these ancient clouds. They never hurry. No cloud worries about tomorrow. None attempts to force gravity's schedule. Each simply gathers, patiently, faithfully, allowing nature to unfold one quiet moment at a time. Perhaps that is why stellar nurseries feel strangely comforting. They remind us that becoming often takes far longer than arriving. The most meaningful transformations are rarely sudden. Roots grow long before flowers bloom. Morning light slowly replaces night. Stars spend millions of years preparing for a sunrise that lasts billions more. Our own lives often follow the same quiet rhythm. Dreams begin as invisible thoughts. Understanding grows through countless unnoticed moments. The person we eventually become starts forming long before anyone else recognizes the change. Like the ancient molecular clouds, we are often becoming long before we begin shining. The universe has always understood this gentle truth. Its brightest stars begin inside its darkest places. Its greatest light is born from its deepest silence. Its longest journeys begin with almost imperceptible movement. And somewhere tonight, deep inside a cold cloud drifting through one of the Milky Way's quiet spiral arms, a tiny pocket of hydrogen is slowly growing denser, gravity patiently drawing invisible atoms together one by one, preparing a sunrise that no living eyes have yet witnessed, a future sun still sleeping beneath ancient veils of dust, waiting, not because it is late, but because the universe has never hurried the birth of its brightest dreams. 9. The light that left before Earth existed. Some of the light entering your eyes tonight began its journey long before our planet had oceans, continents, or even a single living cell. Imagine receiving a letter that has been traveling for nearly 14 billion years, not carried by ships, not delivered by airplanes, not even sent across empty space by some unimaginable machine. Instead, the letter is made entirely of light. Every second, trillions of tiny messengers pass silently through the universe. Most begin their journeys inside nearby stars. Some have traveled for thousands of years. Others have crossed entire galaxies before finally arriving here. But among them are far older travelers, photons that began their endless voyage so incredibly long ago that when they first departed, Earth did not yet exist. There were no oceans, no mountains, no moon circling our planet. Not even the sun had been born. The tiny blue world we call home was still hidden inside a future cloud of gas drifting through the Milky Way. Yet those ancient beams of light were already moving, patiently, relentlessly, crossing an expanding universe that would continue changing for billions upon billions of years before finally meeting human eyes. Tonight, we'll follow one of those extraordinary travelers. We'll discover why light can become the greatest historian in the universe. How every telescope is really a machine for looking backward through time. And why the oldest light reaching us tonight has quietly witnessed almost the entire history of everything that has ever existed. We usually think of light as something immediate. Flip a switch, the room becomes bright. Watch the sunrise. Morning arrives almost instantly. Stand beneath the stars. Their gentle glow seems to belong entirely to the present moment. Our everyday experience hides a remarkable truth. Light is incredibly fast. Nothing in the universe travels faster. Yet the universe itself is unimaginably large. Even at nearly 300,000 kilometers every second, light still requires time to cross cosmic distances. Sunlight reaches Earth in about 8 minutes. When you watch the sun setting below the horizon, you're actually seeing it as it looked 8 minutes earlier. If the sun could somehow vanish instantly, a purely imaginary scenario, Earth would continue receiving its light for another 8 minutes before darkness arrived. Already, the present is beginning to blur. The farther we look into space, the farther backward we look into time. The moon appears as it was about 1 second ago. Jupiter appears roughly 40 minutes in the past. The nearest star beyond the sun, Proxima Centauri, is seen as it existed more than 4 years ago. Every additional distance becomes an additional chapter of history. Looking outward is never separate from looking backward. Imagine standing beside a peaceful lake. A child tosses a pebble into the water. Ripples slowly spread outward. If you stand close to where the pebble landed, the waves reach you quickly. Stand much farther away, and they arrive much later. The ripples preserve a memory of something that happened long ago. Light behaves in much the same way. Every photon carries information from the moment it was released. As long as nothing destroys or absorbs it, that information continues traveling through space. In many ways, the universe never forgets. It simply stores its memories inside moving light. When astronomers observe the magnificent Andromeda galaxy, they are seeing it as it appeared roughly 2.5 million years ago. At that time, our own ancestors were only beginning to shape the earliest stone tools on Earth. Human civilization would not emerge for an unimaginably long time. Yet the light arriving tonight still carries that ancient image. The galaxy we observe no longer exists exactly as we see it. It has continued evolving throughout those millions of years. The photograph reaching us is wonderfully old. As telescopes become more powerful, they reach even farther into history. Some galaxies observed by the James Webb Space Telescope emitted their light more than 13 billion years ago. They appear as tiny reddish smudges against the darkness, yet those faint points represent some of the earliest galaxies ever formed. Their light departed when the universe itself was still astonishingly young. In a sense, these are baby pictures of the cosmos. The galaxies have long since changed. Many merged with neighbors. Some grew enormously. Others disappeared altogether. But their ancient light continues traveling, patiently preserving moments that would otherwise have been lost forever. One of the most extraordinary discoveries in modern astronomy is the cosmic microwave background. This faint glow fills every direction of the sky. Unlike ordinary starlight, it was released approximately 380,000 years after the Big Bang, when the young universe finally became transparent enough for light to travel freely. Before that time, space was filled with a hot plasma that constantly scattered photons. Light could not move very far. The universe resembled an endless glowing fog. Then everything changed. As temperatures cooled, electrons combined with atomic nuclei to form neutral hydrogen. Suddenly, light escaped. Many of those same photons are still traveling today. For nearly 13.8 billion years, they have crossed the expanding universe almost completely undisturbed. Some entered radio antennas here on Earth only decades ago, allowing scientists to create the first complete images of the infant universe. Those tiny microwaves are among the oldest travelers that will ever reach humanity. Imagine hearing the faint echo of a bell that rang before mountains had formed. That is almost what astronomers experience when studying the cosmic microwave background. They are listening to the universe remembering its own childhood. Light also tells us something deeply reassuring. Although everything changes, nothing truly disappears without leaving a trace. Every sunrise sends photons racing outward forever. Every star continually writes its autobiography into space. Every galaxy quietly broadcasts its existence across billions of light years. Most of those messages will never be received. Some travel into regions where no planets exist. Others continue toward galaxies whose civilizations, if any ever arose, may already have vanished. Still, the messages continue, patiently crossing the darkness. There is something profoundly beautiful about that persistence. Some photons now entering your eyes tonight may have spent billions of years avoiding dust clouds, black holes, colliding galaxies, and expanding space itself. Their journey was unimaginably fragile. One tiny grain of dust could have absorbed them. One cloud of gas might have scattered them elsewhere. Yet somehow, after crossing distances almost beyond comprehension, they arrived here, to this planet, at this moment, into your eyes. The probability feels almost miraculous. Astronomers sometimes say that telescopes are time machines. Of course, they cannot carry us into the past, but they allow the past to visit us. Every observation becomes a conversation with history. Every distant galaxy becomes a memory preserved in light. Every new image expands not only our map of space, but also our understanding of time. Perhaps this changes how we think about the night sky. Those stars are not simply decorating the darkness. They are telling stories. Some began before human civilization, some before mammals, some before Earth itself. Every beam carries news from another age. Every photon whispers, "This is what the universe once looked like." There is something comforting about living inside such a patient cosmos. The universe never rushes its stories. It allows light to carry them slowly across unimaginable distances. Perhaps our own memories work in similar ways. A single conversation can continue shaping us decades later. A quiet act of kindness can travel through generations. The past is never entirely gone. It simply arrives later, carried by invisible messengers. The universe has always understood this. Its oldest stories are written not in books, but in light, not preserved inside libraries, but scattered across the expanding heavens, waiting for curious eyes to finally receive them. And somewhere tonight, far beyond every familiar constellation, another ancient photon continues its endless voyage, passing lonely galaxies that did not yet exist when it first departed, crossing expanding rivers of darkness that have stretched for billions of years, still carrying the untouched memory of a young universe, still searching for someone who might one day understand the story it has been patiently telling. Ever since it left home, long before Earth itself, had even begun to dream. 10. The bridges that carry entire galaxies. Galaxies are not simply scattered through space. They slowly travel along invisible bridges that have guided them since the earliest moments of the universe. Imagine standing high above a mountain range at dawn. The valleys below appear empty at first. Then, as the morning mist begins to lift, hidden roads slowly reveal themselves. Some wind gently through forests. Others cross rivers on graceful bridges. Villages that once seemed completely isolated are suddenly connected by countless invisible paths. The roads were always there. The fog simply hid them. The universe has its own hidden roads. When we look into the night sky, galaxies appear scattered almost randomly across the darkness. Some seem close together, others drift alone. It feels almost accidental, as though someone tossed billions of glowing islands across an endless black ocean. But that picture is an illusion. Galaxies do not wander aimlessly. For nearly 14 billion years, they have been quietly traveling along enormous invisible bridges that stretch across the entire observable universe. These bridges cannot be seen with ordinary eyes. They emit almost no visible light. Yet, they have patiently guided rivers of gas, immense clouds of dark matter, and even entire galaxies since the universe was still astonishingly young. Tonight, we'll journey across these forgotten highways. We'll discover why galaxies almost never build their lives alone, how invisible bridges continue feeding the largest structures in existence, and why our own Milky Way may still be traveling along a road that first appeared before the earliest stars had even begun to shine. From our perspective on Earth, space often appears perfectly still. The constellations seem fixed. The Milky Way stretches quietly across the sky. Night after night, everything appears almost unchanged. Yet, this peaceful appearance hides an extraordinary truth. Nothing in the universe is truly standing still. Earth circles the sun orbits the center of the Milky Way. The Milky Way itself moves through space. Nearby galaxies drift. Galaxy clusters slowly fall toward one another. Even the largest structures ever discovered continue evolving. The universe is filled with motion so slow that human history captures only a single frame of an unimaginably long journey. But galaxies rarely choose their directions randomly. Their paths are shaped by invisible structures far larger than themselves. Earlier, we explored the first delicate threads of the cosmic web. Those ancient filaments became the skeleton of the universe. Now, we discover something even more remarkable. They are not merely structures, they are highways. Imagine rain falling onto an enormous mountain landscape. Every drop eventually finds a valley. Small streams merge into rivers. Rivers join larger rivers. Without anyone directing them, nearly every drop follows paths carved by gravity. The water is free to move, yet the shape of the land quietly determines where it ultimately goes. The cosmic web behaves in much the same way. Dark matter forms immense filaments stretching across millions of light years. Ordinary hydrogen gathers inside those filaments. Galaxies gradually emerge within them. Then gravity continues guiding everything along those same invisible routes. The bridges never force motion. They simply make certain directions easier than others. Over billions of years, that gentle guidance becomes impossible to ignore. One of the most fascinating discoveries in modern astronomy is that galaxies continue receiving fresh material through these cosmic bridges even today. For many years, astronomers wondered how spiral galaxies like our own Milky Way continued forming new stars for billions of years. Stars constantly consume hydrogen. Surely, the available fuel should eventually run out. Yet many galaxies continue producing stars generation after generation. The answer appears to lie inside these invisible bridges. Hydrogen gas slowly flows along the filaments toward galaxies. The journey is astonishingly slow. The gas may require hundreds of millions or even billions of years to reach its destination. But eventually it arrives. Fresh material settles into galactic disks. New molecular clouds form. Gravity begins gathering those clouds together. And somewhere inside the quiet darkness, another generation of stars awakens. The bridge has quietly delivered tomorrow. Imagine an ancient stone aqueduct carrying water toward a distant city. The people inside the city may never see the mountains where the water first began its journey. Yet every fountain, every garden, every drink depends upon that hidden connection. The cosmic web nourishes galaxies in much the same way. Without these invisible highways, many galaxies might have exhausted their fuel long ago. Even galaxy clusters continue growing through these enormous bridges. Clusters are among the largest gravitationally bound structures in the universe. Some contain thousands of galaxies. At first glance, they appear like enormous cosmic cities. Yet even these giant cities continue receiving new arrivals. Smaller galaxies slowly travel inward along surrounding filaments. Entire groups of galaxies merge together over billions of years. The city never truly finishes growing. Construction quietly continues. Astronomers have observed enormous filaments connecting some of the largest galaxy clusters ever discovered. Although much of the bridge consists of invisible dark matter, faint hydrogen gas sometimes reveals its presence. X-ray telescopes detect incredibly hot gas stretching between neighboring clusters. Gravitational lensing shows invisible mass bending light exactly where these bridges should exist. It is rather like watching wind move through a wheat field. You cannot see the wind itself. You only notice the graceful waves it creates. Dark matter remains invisible. Its bridges reveal themselves through everything they gently guide. One especially beautiful aspect of these cosmic roads is their incredible scale. On Earth, bridges connect neighborhoods, or perhaps cities. The universe builds bridges that connect regions hundreds of millions of light years apart. If our planet were reduced to the size of a grain of sand, many of these structures would still extend farther than entire continents by comparison. Human language struggles to describe distances so immense, yet gravity patiently spans them all. The Milky Way itself occupies one branch of this vast network. Together with the Andromeda Galaxy, the Triangulum Galaxy, and dozens of smaller companions, we belong to the local group. The local group is itself moving toward the larger Virgo cluster, guided by the gravitational landscape surrounding us. Far beyond Virgo lies even larger structures. Every level belongs to something greater. Every bridge becomes part of an even larger network. The universe resembles an endless system of rivers flowing into wider rivers, each eventually joining an ocean too vast to comprehend. What is perhaps most comforting is the pace at which all of this unfolds. Nothing hurries. Galaxies require billions of years to cross a single filament. Clusters grow so slowly that no human civilization could ever witness their complete evolution. Gravity never becomes impatient. It simply continues pulling, one tiny motion at a time. Perhaps this quiet persistence explains why the universe feels strangely peaceful despite its immense complexity. Everything belongs somewhere. Everything follows gentle pathways laid down long before it arrived. Perhaps our own lives contain invisible bridges as well. Looking backward, many important moments seem connected in ways we never noticed while living through them. A single conversation, a chance meeting, a small decision made years earlier. Each quietly guided us toward places we'd never expected. The road was invisible until we had already traveled it. The universe has been teaching this lesson since its earliest days. Its greatest journeys rarely happen through sudden leaps. They unfold through patient guidance, gentle attraction, invisible connections stretching farther than anyone can immediately see. And somewhere beyond the farthest spiral galaxies visible tonight, an ancient bridge of dark matter continues spanning millions of light years. carrying quiet rivers of hydrogen toward galaxies still waiting for their future stars, guiding enormous islands of light through the expanding darkness, following a path first traced almost 14 billion years ago, when the universe itself had barely begun, and the first invisible bridges quietly started carrying the future across the endless sea of space. 11. The quiet places time almost forgot. While much of the universe has changed beyond recognition, a few forgotten corners remain astonishingly similar to the cosmos that existed billions of years ago. Imagine discovering an old cabin deep within a forgotten forest. Its wooden walls have weathered countless winters. The roof has faded beneath centuries of rain. Yet, when you gently open the door, everything inside seems almost untouched. A chair still rests beside the fireplace. An old lantern waits patiently on the table. Dust hangs quietly in the air, as though time itself had decided to walk more slowly here. Outside, generations have come and gone. Empires have risen and disappeared. Entire landscapes have transformed. But inside this quiet little room, the past still breathes. The universe contains places very much like that forgotten cabin. While galaxies collide, stars explode, black holes grow, and the cosmos continues expanding in every direction. A few remarkable regions have remained astonishingly peaceful. They have changed so little that studying them is almost like opening a window into the early universe itself. They are not frozen. Time has never truly stopped there. But compared with the restless activity unfolding elsewhere across the cosmos, these quiet places seem almost forgotten by history. Tonight, we'll visit these extraordinary survivors. We'll discover why some regions have remained nearly unchanged for billions of years, how ancient stars preserve memories older than our sun, and why the calmest corners of the universe may quietly contain some of its oldest stories. When people imagine the universe, they often picture constant motion, exploding supernova, colliding galaxies, stars forming inside glowing nebulae. Everything seems energetic, everything appears dramatic, and much of the universe truly is. The Milky Way slowly rotates, galaxies merge, gas clouds collapse, gravity continually reshapes the largest structures in existence. The cosmos is wonderfully alive, yet activity is not distributed evenly. Some neighborhoods remain surprisingly calm. Imagine two rivers. One rushes through steep mountains, carving new valleys every year. The other drifts gently across a wide plain, changing so slowly that generations scarcely notice its movement. Both rivers continue flowing. But one tells a much quieter story. The universe contains regions like the second river. Perhaps the most remarkable examples are globular clusters. These enormous spherical collections of stars orbit the outskirts of galaxies like ancient lanterns suspended in the darkness. Some contain hundreds of thousands of stars packed closely together. Others contain more than 1 million. What makes them extraordinary is not simply their beauty, it is their age. Many globular clusters formed more than 12 billion years ago. Some appeared only a few 100 million years after the Big Bang. Long before our sun existed, long before Earth formed, long before the Milky Way looked anything like it does today. These ancient stellar cities were already shining. When astronomers study them, they are not merely observing old stars. They are studying survivors from the earliest chapters of cosmic history. One particularly famous example is Messier 92, a globular cluster located roughly 27,000 light-years away. Its stars are among the oldest ever discovered in our galaxy. Many have been quietly orbiting one another since the universe was still in its childhood. Imagine attending a family reunion where every guest is older than nearly every mountain, ocean, and continent on Earth. That is something close to what astronomers experience when they observe these ancient clusters. Their stars remember an era no planet can recall. Unlike the crowded spiral arms of the Milky Way, where new stars continually form and old ones eventually explode. Globular clusters have lived remarkably peaceful lives. Most of their gas disappeared billions of years ago. Without fresh hydrogen, very few new stars could form. The brilliant blue giants that once illuminated these clusters have already completed their lives. What remains are long-lived, smaller stars that continue shining quietly through unimaginable stretches of time. The cluster slowly grows older together, like an ancient village whose youngest residents have all become grandparents. Beyond these clusters lie even quieter places. Astronomers have discovered tiny ultra-faint dwarf galaxies, some containing only a few thousand stars. Compared with the Milky Way's hundreds of billions of stars, they seem almost insignificant. Yet, these fragile galaxies are extraordinary time capsules. Many experienced only one brief period of star formation shortly after they were born. After that, almost nothing happened. They drifted through billions of years with very little change. The stars inside them preserve the chemical fingerprints of the early universe. By studying their light, astronomers can learn what the cosmos was like before later generations of stars enriched space with heavier elements. These galaxies resemble pages from a history book that somehow escaped every revision. Another remarkable quiet place exists not within galaxies, but between them. Earlier, we explored the enormous cosmic voids stretching across millions of light years. These vast regions contain astonishingly few galaxies. Because gravity is weaker there, evolution proceeds more gently. Galaxies inside voids experience fewer collisions, fewer close encounters, fewer dramatic disturbances. Some have remained relatively isolated for billions of years. Their peaceful surroundings allowed them to evolve far more slowly than galaxies living inside crowded clusters. It is almost like comparing a bustling city with a remote island. Both experience the passage of time, but life unfolds very differently. Perhaps one of the most beautiful examples of cosmic memory comes from certain ancient stars themselves. Astronomers have identified stars containing extraordinarily small amounts of heavy elements. Since the earliest universe produced almost nothing beyond hydrogen and helium, stars with very few heavier elements must have formed incredibly early. Some of these ancient suns still shine today. They have quietly survived while countless younger generations appeared around them. Every photon leaving their surfaces carries chemical clues from an age when the universe was still learning how to build complexity. They are among the oldest storytellers still speaking. Even our own galaxy contains quiet neighborhoods. Far above the bright spiral disk lies the galactic halo, a vast spherical region sparsely populated by ancient stars and globular clusters. The halo changes slowly. Few new stars form there. Gas is scarce. Collisions are uncommon. Compared with the lively spiral arms where our sun resides, the halo feels almost timeless. Its stars drift through immense orbits, lasting hundreds of millions of years. Many have circled the Milky Way dozens of times already. They continue their patient journeys without urgency. There is something deeply comforting about these forgotten places. The universe often celebrates transformation. Stars are born. Stars die. Galaxies collide. Everything seems temporary. Yet, these quiet regions remind us that not every story depends upon dramatic change. Sometimes endurance tells the more remarkable tale, remaining, remembering, quietly preserving what almost everything else has forgotten. Perhaps our own lives contain such places. An old photograph tucked inside a drawer, a childhood home still standing at the end of a familiar street, a favorite book whose pages smell exactly as they did years ago. These places do not resist time, they simply carry it gently. The universe has been doing the same thing for nearly 14 billion years. It has preserved small corners where the earliest chapters remain beautifully readable, not because they escaped time, but because time treated them with extraordinary kindness. and somewhere tonight. Far beyond the bright spiral arms of the Milky Way, an ancient globular cluster continues drifting silently through the galactic halo, its oldest stars still shining with the same gentle light they first released when the universe was young. Its quiet streets of starlight, almost unchanged through billions of years, patiently guarding memories older than Earth, older than the sun. Almost as though, in that peaceful corner of the cosmos, time itself had decided to whisper instead of rushing forward. 12. The last pattern. The universe will remember. Even after countless stars have faded, one enormous pattern may continue stretching across the darkness, preserving the universe's final memory of itself. Imagine walking through an ancient city after everyone has gone. The streets are empty, the windows are dark. The voices that once filled every corner have long since fallen silent. Yet from high above, the city's design still remains. The roads still intersect. The bridges still connect distant neighborhoods. The avenues still trace the careful plan imagined by builders centuries before. The people are gone. The lights have disappeared, but the pattern survives. The universe may one day reach a similar moment. There will come an age when the brilliant stars that decorate our night sky have finished their long lives. Galaxies will grow dim. Nebulae will no longer glow with newborn suns. Even the greatest stellar cities may slowly fall into silence. And yet, something astonishing may remain. The immense cosmic pattern first woven shortly after the birth of the universe may continue stretching across the darkness for unimaginable lengths of time. Invisible, patient, almost unchanged. Long after the lights have faded, the architecture itself may still endure. Tonight, we reach the final chapter of our quiet journey. We'll imagine the distant future awaiting the cosmic web. We'll explore what the universe might still remember after nearly everything familiar has disappeared. And we'll discover why the last surviving masterpiece may not be a single star, planet, or galaxy, but the invisible pattern that quietly connected them all from the very beginning. Throughout our journey together, we've discovered a remarkable truth. Nothing in the universe truly exists alone. The oldest stars survived because gravity first gathered tiny clouds together. Galaxies grew because invisible rivers continuously delivered fresh hydrogen. Ancient light carried forgotten stories across billions of years. Hidden bridges quietly guided galaxies toward one another. The oldest stellar neighborhoods preserved memories from the universe's youth. Every chapter revealed another connection, another thread, another gentle reminder that the universe has always preferred relationships over isolation. Now, we arrive at the question, waiting patiently behind every previous mystery. What happens when almost everything ends? At first, the answer seems heartbreaking. Stars cannot shine forever. Every sun is quietly spending the fuel stored inside its core. Massive stars burn through their lives quickly. Smaller stars survive far longer. Tiny red dwarfs, the most common stars in the universe, may continue shining for trillions of years. Compared with our sun's lifetime of roughly 10 billion years, they are astonishingly patient, but even they possess limits. Given enough time, every ordinary star eventually changes. Some gently become white dwarfs, others collapse into neutron stars. The most massive leave behind black holes. The brilliant night sky we know today slowly grows darker, not suddenly, not dramatically, simply one quiet sunset after another. Imagine visiting a vast forest where each tree lives for a different length of time. Some fall after only decades, others survive for centuries. The forest changes slowly, year after year, generation after generation, until eventually only the oldest trees remain. The future universe follows a similar rhythm. Stars disappear gradually. Galaxies become calmer. New star formation slows as the available hydrogen is steadily consumed. Eventually, enormous galaxies may contain mostly stellar remnants, quietly orbiting through the darkness. Yet something extraordinary continues surviving: gravity. Gravity never needed light. It never depended upon shining stars. Long after galaxies become dim, their gravitational relationships continue. Dark matter halos still surround them. Invisible filaments still connect enormous regions of space. The cosmic web does not suddenly dissolve simply because the stars have grown old. The roads remain even after the travelers have gone. Imagine looking at an ancient railway map long after every train has stopped running. The stations remain marked. The tracks still connect distant cities. The design continues telling the story of how everything once moved together. The cosmic web may become something very similar: a silent map of a universe that was once brilliantly alive. Some computer simulations exploring the unimaginably distant future suggest that galaxy clusters will become increasingly isolated. As cosmic expansion continues accelerating, enormous distances between clusters grow even larger. Eventually, many galaxy groups may disappear beyond one another's observable horizons. Each surviving island of galaxies becomes a lonely universe unto itself. Inside those islands, gravity continues holding stars, stellar remnants, planets, and black holes together. Outside, darkness quietly expands. Even then, traces of the original pattern remain. Each isolated cluster still carries the memory of where the ancient filaments once gathered matter. Every galaxy still reflects the invisible architecture that shaped its birth. The design never entirely disappears. It simply becomes more difficult to see. There is something profoundly moving about this idea. We often imagine memory as something fragile, something easily lost. But the universe remembers differently. It remembers through structure, through motion, through relationships that persist long after individual objects have changed. The oldest stars preserved chemical memories. Ancient light preserved visual memories. The cosmic web preserves spatial memory. It remembers where everything belonged. Modern astronomers sometimes describe the universe as a kind of evolving network. Nodes connect through filaments. Matter flows along invisible pathways. Growth follows ancient patterns established shortly after the Big Bang. Although individual galaxies continuously change, the larger design evolves much more slowly. It is rather like watching leaves appear and disappear upon the branches of a great tree. Every season changes the leaves. The tree itself quietly remains. Perhaps that is why the cosmic web feels strangely comforting. It reminds us that permanence is not always found in individual things. Sometimes permanence belongs to patterns. A melody survives even when one performance ends. A constellation remains recognizable even though its stars slowly move. A family continues although generations come and go. The pattern quietly outlives its individual pieces. The universe has been teaching this lesson since its earliest moments. Its greatest masterpiece was never a single galaxy, never a single star, never even a trillion stars. Its masterpiece has always been the invisible harmony connecting them all. Perhaps our own lives resemble that quiet architecture more than we realize. Individual days pass quickly. Years seem to disappear. Faces change, homes change. Entire chapters quietly come to an end. Yet beneath those changing moments runs a deeper pattern. The people who shaped us, the kindness we received, the curiosity that led us to keep asking questions, the quiet habits that slowly built who we became. Those invisible threads often outlast the moments themselves. Perhaps that is why looking at the universe sometimes feels strangely personal. Its story is written on a scale beyond imagination. Yet its deepest lesson feels wonderfully familiar. Lasting beauty is rarely found in holding everything still. It is found in the relationships that continue even as everything changes. And so, as our journey through these quiet cosmic mysteries gently comes to an end, we leave the universe not with an explosion, not with a final blaze of light, but with a pattern, an invisible masterpiece stretching across unimaginable distances, patiently connecting galaxies that have spent nearly 14 billion years growing together, quietly preserving the memory of a universe that never stopped creating, even as its oldest stars slowly faded into history. Somewhere beyond every constellation you'll ever recognize, beyond every galaxy whose light will one day disappear, beyond the final generation of stars still glowing in the darkness, the ancient threads of the cosmic web may continue spanning the silent cosmos, holding the last great shape the universe will ever remember. A masterpiece woven from gravity, written across eternity, and patiently waiting for anyone willing to look beyond the light, to discover the quiet design that had been there all along. If these gentle explorations help you end your evening with a little more wonder, consider subscribing, and I'll be here for our next quiet journey through the universe.